enabling application traffic routing. So GSLB feature, what is GSLB doing in this case for DNS? Right, we have the use case, 5 use case, right? Basically the different methods of deploying GSLB, right? And how to configure and the description of the GSLB. So GSLB description. Right, so the purpose of GSLB is to direct the user to the highly available or the active application server, right? The DNS server can only reply with the IP address, right? And in order to provide the client with the appropriate server that is available, the DNS server itself will do a health check, right? So what we try to achieve is we do not provide the client with the service that is already down. So if we detect the web service down, we will direct the clients to a server that is already active, right? And we can also perform our health check to find out what is the latency between the DNS server and the application, right? And direct the client to the nearest one. So there are 2 ways to set this up, right? In the question in the email, what is the difference between the core and the edge setup? So I will also address that. Right, so client perform the query, DNS responds with the IP address, the client connects directly to the application, right? We are not doing any interception of the web traffic. We only provide DNS-based direction. Okay, this is the main word here, DNS-based redirection. So this is just saying that when you deploy GSLB, you will help to reduce latency, right? So in a huge country like Korea, for example, if you have branch offices, but your data center is located in very far off locations and you want the users to be directed to the one that has lowest latency, that can be done. You will also want sort of HA so that the clients can always access the application that is always up, right? And also allow non-disruptive migration to other cloud and other data center. And so for example, you have some servers that is going to be under maintenance. You don't want your clients to access this server that's going through maintenance. You can redirect them to the other servers that is active. Right, so EfficientIP GSLB server is hosted on the recursive DNS server, right? The purpose is for on the edge deployment, right? So this is a bit different from other implementations on the market, where the GSLB function is always nearest to the application server, right? For example, the F5, the Fortinet, GSLB stuff, they are mostly on the data center, but ours is on the recursive DNS server nearest to the client. This is the edge GSLB. So example over here, the client will have the solid server in their environment, in their offices, for example, right? So when the client requests for CRM.intranet, the clients in France will be directed to the one in New York City, for example. And the ones in Australia will be directed to the one in Singapore. Right, so this is a solid server within their edge environment. So in case of any failure, because the recursive or the GSLB is performing health check, so when the New York City data center goes down, it will automatically redirect the clients to the one that is active, which is in Singapore. Right, so this is how the GSLB in Solid Server works. Okay. So this is the GSLB message flow. Client query the DNS for this particular FTDN CRM. DNS performs query to the CRM intranet.a that gets this IP address 107015, selects the server based on GSLB traffic policy, the fastest one, in this case, responds to sends the response back to the client then connects directly to the CRM server nearest to their location. Okay, this is the same thing with more detail. So take note, GSLB for EfficientIP can only handle A and quad A records only. Okay, if the client has other records like CNAME, MX record, TXT record, we cannot load balance that because we can't do a health check on those records, right? We can do a health check on A because A contains the IP address or quad A. And it makes sense because we are checking whether that particular server has its services running or not before we provide the reply to the client. Okay, A and quad A records only. So how does this GSLB server runs on a recursive DNS? Again, this is part of the DNS Guardian, right? You will need the GSLB license, but this engine is running on the Guardian portion. It is an extension of the Guardian capability. So the cache engine is separated from the recursive engine. Again, like Guardian, right? It's one layer below the bind or outbound. It has its own cache. The GSLB has its own cache. And the GSLB is able to relay queries to the co-hosted recursive DNS engine if the answer to the query is not in the cache. Something like DNS Guardian also. So message flow for the DNS service with GSLB is client perform the query. The response is not in the cache. It forwards the query to the local recursive engine, and then the query resolves the authoritative name server of the engine of the name server, provide the answer. The recursive DNS engine provides the response and store in the cache. GSLB substitute the response, right, based on the health check, and then reply back to the client. So the client can now connect directly to the application. So this is the recursive DNS GSLB. Right. So in this example, you have applications in the cloud, applications on-prem. Right. So you can do a health check between the cloud and the on-prem. So if the on-prem fails, you can straight away direct the clients to the cloud. Right, and this is also true if the server is not hosted by Solid Server, because it is again doing the recursive queries to the internet to resolve and giving back the lowest latency server. So what happens if the answer is already in the cache and the TTL is valid? So the answer is immediately sent back to the client, and the client resolves directly or connects directly to the server. Both Guardian and GSLB services can be enabled on an appliance. So if you have customers that wants Guardian and GSLB to be running on the same box, that is still possible, right? And it allows the DNS appliance to take advantage of Guardian capability. Right? And GSLB supports the high availability architecture, so using VIP or anycast routing. Right? So it is possible to use Guardian and GSLB on the same server. Object model. Firstly, you have the application, which is the FQDN of the FQDN of the application that you're trying to access. And then you create a pool which contains the node. And each node will then be perform a health check by the GSLB engine. Okay, so again, you can still manage GSLB servers from the CM or the centralized manager. Right, you can have as many GSLB as you want, and everything can be managed centrally. The application traffic policies are bound to individual GSLB servers. Right, so this one is like a mesh setup, but you can see that GSLB1.intranet has two applications, application 1 and application 2. Each one has its own health check being performed by the GSLB server itself. So GSLB2 also has application 1 and application 2, and also performs the health check itself. So what this thing does is each DNS server is actually performing the health check and checking the connectivity and responding to the client based on what it sees on the application. So the response returned to the client results of the application traffic policy execution by the GSLB server. Client queries the application FQDN, right? It hits the pool. Then based on the load balancing mode, right, which is the 3 modes, weighted, round robin, latency. Then a weight, for the weighted one, a weight is assigned to the nodes to create a preference list. And when there is no selection, then a fallback value is used. So this is how the policy is executed. So basically the traffic reaches the DNS checks the mode, sees the whichever mode that is being deployed, and then identify which node has the best answer for it and provide the answer to the client. So what is the difference between the 3 modes of load balancing? Round robin is basically having the same weight for all the nodes, right? Each one will have a weight of 1, and the traffic will be equally distributed. For the weighted one, you can actually set the weightage, right, based on a value from 1 to 10, for example, right? And that determines the number of sessions that will be sent to the application. So in this example, you can see the weightage is 4411. So 40% of the traffic will be sent to the 2 on the left, and 10% of the traffic will hit the other 2 on the right. So latency decides which node has the lowest latency, right? And it provides the number of nodes that you want to be responded with to the client. So for example, when you set the n equals to 2, it means that the DNS server must respond to the client with at least 2 application IP address. Okay. So the latency will always do a health check, and find out what is the speed within the server and the DNS, right? And since n equal to 2, the DNS server must send the one that has the top 2 lowest latency. Right, so in this example is the 10 millisecond and the 15 millisecond server will be equally load balanced. Right, you can also set n to 1, which means you will only send the one which has the lowest latency first to the client. So for GSLB to be supported, only these appliances or models can support GSLB, right? The 7070 is meant to be the CM, so that's why we don't provide any Guardian or Blast licenses for it. 3370, it says here can only run DNS service, but does not support GSLB and Guardian configuration. Okay, so again, sizing will be done by EfficientIP, so we will provide the appropriate sizing for it. Sizing and performance information. So the maximum number of application objects per GSLB server is 256. You can only have 1 pool per application. You cannot have more than 2 pools per application. Right? So example, you have www.whatsapp.com. You can only create 1 for it. Then max number of nodes per pool is 8. This one can also be extended by the registry key. So this one, when you need to, you can get in touch with me on how to extend this, and I will provide the steps. So it's just basically changing the value in the registry key.